In lesson 3.6, we're going to continue our work on factoring polynomials, and our focus is going to be on factoring those that are trinomials, those that have three terms. In class yesterday, we were looking at the special cases where we've got factoring a difference of squares that has two terms, factoring a difference of cubes that has two terms, and factoring a sum of cubes that has two terms. These polynomials will have three terms. So we want to be able to factor trinomials that are just in the form 1x squared plus something times x plus a constant. We also want to be able to factor trinomials that are in the form maybe y equals 2x squared plus something times x plus a constant. And then we'll talk about another special case, which is factoring trinomials that are known as perfect square trinomials. And then we'll just provide a summary. And then in class on Monday, I'll have a factor card for you that has this summary on it that I talked about in class yesterday, where we're going to, okay, step 1, we look for the greatest common factor. Step 2, we're going to look for whether or not it's a special case. Step 3, and so on. So one of the most common types of factoring is just to factor a trinomial that's in the form 1x squared plus something like 8x plus 12. Now, when we factor a trinomial like this, what we're basically trying to do is unfoil. We must have had two binomials that were multiplied together to get this trinomial. The question is, what were those two binomials? And in this case, when the leading coefficient, the number in front of the x squared, is a 1, this is pretty easy to factor just by trial and error. What we want to think about is the fact that we know that first times first has to equal x squared. So that means that what's first in one binomial and in the other binomial is going to be x, because x times x is x squared. We also know that when we do last times last, it's going to equal that number 12. So we need to find two integers that multiplied together equal 12. But then we can't forget that when we FOIL, we have to also multiply the outside terms and the inside terms, and those typically can be combined as one term. So the sum of the products of the outside term and the inside term must add up to this middle term here, 8x. So we're basically looking for two numbers that multiplied together equal the constant, 12, but added equal the coefficient of x, 8. So when I think about combinations of factors of 12 that add up to 8, I think 1 and 12 multiplied together equal 12, but they don't add up to 8. 2 times 6 multiplied together equal 12, and they do add up to 8. 3 times 4 multiplied together equal 12, but those add up to 7 rather than 8. Therefore, the correct values that we will put last in our binomials must be 2 and 6, because they're the only pair of factors of 12 that add up to 8. Okay, now you can always refoil this or use the rectangle method to multiply these binomials to make sure that they do in fact equal the trinomial we started with. First times first, x times x is x squared. Outside times outside, x times 2 is 2x. Inside times inside, 6 times x is 6x, and combine that with a 2x and you have 8x. And then last times last, 6 times 2 is 12. So what about when we have a number in front of the x squared other than a 1? These are a little trickier, but still can be done by trial and error, especially when the number out in front maybe only has one pair of factors. Like if that's a 3 out in front, well, there are only two numbers that multiply together that equal 3, and they're 1 and 3. Or if that number in front is a 2, there are only two numbers that multiply together equal 2, and that's 1 and 2. So when that leading coefficient only has one pair of factors, trial and error is probably going to be the most efficient way of factoring that trinomial. We'll show you a a method, a more systematic method that we can use when that number in front maybe has more than one pair, like the 12 that we were just dealing with in the previous example. So here I have a trinomial because it has three terms. The leading term is 2x squared. Well, 2 only has two factors, 1 and 2. So we know our binomials are going to begin with a 1x and a 2x. That's guaranteed, okay? But the question is then, what is going to be last in each of those binomials? Well, again, last times last has to equal the constant in that trinomial. Well, there are only two values that multiplied together equal 5, two whole number values, and they are 1 and 5. So the 1 could go with the x and the 5 with the 2x, or the 1 could go with the 2x and with the 5 and the 5 with the x. The question is which one's going to work. So these are our two possibilities. We need to pick the one such that when you multiply the outside products and multiply the inside products and combine them, they add up to the middle term, 11x. We'll try the option on the left. Outside would be x times 5, that's 5x. Inside would be 1 times 2x, that's 2x. 5x plus 2x add up to 7x. That doesn't work. They need to add up to 11x. So try the one on the right. Outside times outside would be x times 1, or 1x. Inside times inside would be 5 times 2x, or 10x. 1x and 10x add up to 11x. That's what we need. That's why there is only one correct set of factors for this trinomial, and it was the one on the right. The one on the left produced the wrong middle term.